I want to get the setting for this talk right first and talk about where we live in our galaxy, because we need that context clear in our minds. Now, we have the benefit of a really good video projector here, and this image here shows us what the Milky Way looks like from the southern sky. If you go to South America or Australia, South Africa, if you're lucky enough to be up in the Andes Mountains on a really clear night, this is an incredibly bright object that arcs right over the sky at night, far brighter than anything we see here in the northern hemisphere. Now, the reason being is that the centre of our galaxy is oriented towards the southern hemisphere of the Earth. So here in the northern hemisphere, when we look out on a really clear night, very, very dark, if you can be somewhere like that, and you can actually see that band of milky light, what you're doing is looking at the outer edge of the galaxy, because the galaxy is a big disk of stars, and because we're in that disk. So when we look out at night, the stars you see in all directions, they're very close by. But that band of light, the Milky Way, is the disk of the galaxy seen edge on from where we are within the disk. Now, we'll try and make that a bit clearer. I've got an image here of the Whirlpool galaxy, and we think that our galaxy looks very similar to this. Two large spiral arms, a very bright, dense central region of stars. So we think our Milky Way looks much like this. It's quite hard to work out what the Milky Way actually looks like because we're inside it and we're looking out along the edge of it. It's quite hard to work out the shape of it, but a lot of work has been done, and this image shows our best estimate or guide to what we think our own Milky Way looks like. So here we are, here's the Sun, and we're quite a long way away from the centre of our galaxy, about 25,000 light years. So when we see the bright centre of the Milky Way from the southern skies, that light has taken 25,000 years to get to us. So here we are, and you can see two very large spiral arms coming off this central region, which we think is a sort of a bar shape. So that's where we are in our galaxy. It's very large.
Is that the Milky Bar?
Well, you could be, yes, very good. If you were on one edge of the Milky Way and you sent a radio signal to someone on the opposite edge, it would take about 100,000 years for that radio signal to travel that whole distance. So it's very, very big. Now, how many stars are in the Milky Way? Well, no one's counted them individually, but we think that it's something like 100 to 200 billion stars in the Milky Way. So let's have a look at it in a little more detail. I've tipped this image over. We're going to look at this central region here, and we see this brightness and these dark patches. Now, as we go on, what this is will become a little bit clearer. So we'll zoom in, and you can see the incredible bright areas, and then these dark, shadowy bits. So what's going on? Well, obviously astronomers have been able to use more and more powerful telescopes over the last period of years. And of course, as we zoom in, we can see that that brightness is actually all those millions and millions of stars. And you can see them quite clearly here. Each little dot here is a star. Now, in actual fact, the space between them is very large, but because we're looking from such a long way away, it looks to us as this densely bright packed area of individual stars. And these dark areas are where dust is in the way and blocking the light of the stars. And we're going to talk about that more.